I'm Jeff, and this is a video about limit comparison test. Today we'll be learning how to find out if a limit converges using the limit comparison test. The first two things you need is a limit that you're trying to find. Say a of n. You compare this to another limit, such as b over n, by dividing them. Which will create a value, L. If we'll know one of them diverges or converges. Say Bn converges. If L is a finite number, that means A of n also converges. Because no matter what, a finite number divided and multiplied by a finite number will equal a finite number. The same is true for infinite numbers. Any infinite number multiplied by any number will still equal an infinite number. So if b of n diverged and an over bn still equals L, then a of n diverges. If we do not come up with L and come up with a 0 or a infinity, we have to move on to a different comparison test. So I'm going to go with an example. Say you have the sum of 1 over n squared minus ln n equals 2 to infinity. This strongly resembles the p series 1 over n squared, which we know converges. So what we'll do is we'll take this 1 over n squared and divide it by 1 over n squared. This will come out with n squared over n squared minus ln of n. Now we can't really do much of this, so we're going to differentiate it to find the value. So we're going to first use L'Hopital's rule to make this 2n over 2n minus 1 over n. Still can't do much with it, because we're going to plug in infinity and see if it comes up with a real number. So we use L'Hopital's rule again, which brings us to 2 over 2 minus 1 over n squared. Plus 1 squared, sorry. Now, we're going to plug in infinity. Which will make this term very, very small. That'll force this to be 2 over 2 plus 0, which will come up with a L1. Because it's a finite number and it's not 0, it means that this equation converges. Because this equation converges. And that's the limit comparison test.